Hi everybody! In this video, you will learn how to balance chemical reactions. So the first rule for balancing chemical reactions is that the atoms on the left and right side have to be equal, so basically the conservation of mass. And if applicable, charges on both sides have to add up to be the same. So I will give you an example of all of this soon, but let's just do a common example that we've done before. So we know that methane and oxygen gas react to form carbon dioxide and water. Now, you may know this reaction as a combustion reaction, where you burn the methane in oxygen gas and it produces these byproducts. So burning stuff is also known as combustion. So how do we balance this reaction and make sure that the atoms on the left and right are equal? Well, let's see. So this side has 1 carbon, 4 hydrogens, and 2 oxygens. And this side has 1 carbon, 2 hydrogens, and it seems like 3 oxygens. So obviously, both sides don't have the same number of atoms, so we have to make it so that that happens. So let's see what we could do first. So I wrote a little note, and it says for you to deal with the elements found in only 1 compound on each side first. So this means that choose an element that's only found in 1 chemical on each side. So for example, I would not choose oxygen because while oxygen is only found in 1 compound on the left side, it is found on 2 compounds on the other side. So therefore, it is not feasible to start off with oxygen. So how about hydrogen? Well, hydrogen is only found in this, and hydrogen is only found in that. So therefore, it's an element that's found in only 1 compound on each side. So let's deal with that first. So we have 4 hydrogens here and 2 hydrogens here. So I think we have to multiply this by 2 to get 4, and that would match the other side. So now we don't have 2 hydrogens, we have 4 hydrogens now, and we don't have 3 oxygens, we actually have 4 oxygens, and this is because 2 oxygens here and 2 oxygens here. So in previous videos when I've talked about compounds, these subscripts tell you how many atoms are inside the compound, but the coefficient tells you how many of the compounds you have. So for example, this has 2 hydrogen atoms, but there are 2 water molecules because of the 2 coefficient. And to count the atoms, simply multiply the coefficient by, the subscript to get the number of atoms. So since we have 2 hydrogens in each water, and there are 2 waters, then we have a total of 4 hydrogens. So that's how you calculate the number of atoms on both sides if you were just wondering. But now let's get to balancing. So we notice that our carbons are actually balanced, so that's perfect. So what's the only thing that's not balanced? Well, I think the only thing that's not balanced are the oxygens. So let's balance oxygens. On the right side, we have 4 oxygens, and on the left side, we have 2. So if we want to get 2 to 4, why don't we just multiply it by 2? So since oxygen is the only compound containing oxygen, then we multiply this by 2, and that would get us 4 oxygens. And look at that. They're balanced on both sides. Both sides have 1 carbon, 4 hydrogens, and 4 oxygens. So the complete balanced chemical reaction is CH4 plus 2O2 transforms into CO2 and 2 H2Os. So that's how we balance chemical reactions. And notice how rule 2 does not apply since nothing on either sides are charged. And so the total charge on this would be 0, and the total charge on the right side would be 0. So charges are not applicable in this situation because none of the, chemicals have charges. So we ignore rule 2 for now. So in order to get better at this, you just have to practice a lot. So let's do 6 reactions and try to balance them. So our first reaction is water decomposing into H2 gas and O2 gas. So how do we balance this? Well, we know that there are 2 hydrogens and 1 oxygen, and there are 2 hydrogens and 2 oxygens. So we notice that the 2's are equal, but the 1's are not equal. So let's balance out the oxygens. So we need to multiply this by 2, and in order to do that, we have to multiply the number of waters by 2, so the coefficient for this would be 2. And as a result, as a consequence, there are now 4 hydrogens and 2 oxygens. And look, the oxygens are balanced, but now our hydrogens are unbalanced. That could be bad, but don't worry, there's an easy fix to that. We need to multiply the number of hydrogens by 2, so why don't we just add a 2 here? And now we have 4 hydrogens. So 4 hydrogens and 2 oxygens on each side, we have a balanced chemical reaction. So not so bad. I mean, we balanced the oxygens first, but we ended up messing up the number of hydrogens on both sides. So we fixed that, and in the end it all worked out. So in chemical reactions, when balancing them, usually you balance one thing and the other thing gets messed up, but you fix the other thing and, eventually everything gets fixed. So that happens a lot when you're balancing reactions. But let's try another one in order to see what I really mean. So this is another combustion reaction involving CH4O plus O2, which becomes CO2 plus H2O. So how do we balance this? Well, let's count the number of atoms on each side. So on the right, we have 1 carbon, I think 4 hydrogens, and 3 oxygens. On our right side, we have 1 carbon, 3 oxygens. Oh, let me not go out of order. Let's count the hydrogens first. 2 hydrogens and 3 oxygens. So our oxygens are balanced, but our hydrogens are unbalanced. So let's balance that out. So let's multiply this by 2, and in order to do that, we just have to put a 2 next to the H2O. So now we have to start modifying the number of atoms on both sides. So erase. We have 4 hydrogens and 4 oxygens now, since 2 plus, 2 times 1 is 2. So 2 plus 2 is 4. So we face another dilemma. Now our number of oxygens are thrown out of balance, so we need to fix that. So how can we fix this? Let me think. So if we have 3 oxygens and I want to make it 4, I have to basically just add 1 oxygen. So how do we add 1 oxygen? Well, this is 2 and this is 1. So what if I just multiplied this by 2 to get, 2 here, and that would add up to 4 as I wanted. So putting a 2 here would add an additional oxygen on the left-hand side. So let's do that. So if I do that, then we have 4 oxygens, but now everything else is thrown out of whack, unfortunately. So we have 8 hydrogens, and we have 2 carbons. So once again, everything is thrown out of whack, and we could either choose to balance the hydrogens or balance the carbons. So what should we do? Well, we've already balanced the hydrogens once, so I want to balance the carbons now, since, I think it's more worth it to do that. So let's do that. So if we balance the carbons, we need this to be multiplied by 2 in order to get 2 carbons on both sides. So I would put a 2 here, and now everything is thrown out of whack once again. So we have 2 carbons, we have 4 oxygens plus 2 oxygens, that's 6 oxygens. So once again, everything is thrown out of equilibrium. So what can we do now? Well, if we think about this, we can multiply the number of hydrogens by 2. So let's just do that, since it's kind of easy to do that. So let's just make this 4 now. So this would be 4 H2Os. And as a consequence, we have 8 H's, and we have 4 and 8 O's. So that's not good. We just thrown things out of balance even more. Well, actually, no, we haven't. Look, the C's are balanced, the H's are balanced, but our O's are not balanced. And that's an easy fix, because look at this. We just have to add 4 more oxygens on the left side in order to balance it. So we need plus 4 somehow. So that's easy. If we want to add just oxygens, there's a molecule for that. That's O2, or oxygen gas. We can just change the coefficient on this, and all that would do is change the oxygens. And that's what we want, because the C's and H's are balanced. We just have to balance the O's. So let's just make this 3 oxygens, so that the total number of oxygens would be 2, 6, and 8 oxygens. So now we've balanced the chemical reaction. 2 carbons, 8 hydrogens, and 8 oxygens on each side. And we are done with this one for now. Let me erase the 2 and the 6 to not make it confusing. So 2CH4O plus 3O2 makes 2CO2 plus 4H2O. Let's look at our third reaction. We will take ammonia gas. So let me start writing the states now to get all of you used to the states notation. So to put the states, just put a parentheses and put, S, L, or G, or even aqueous as your state of matter. And aqueous is not technically a state of matter, but it's a state at which matter can be in, which is dissolved in water, which is what aqueous means. So NH3 gas plus, let's see, what's our second gas? HCl gas will make NH4Cl solid. Notice that this is a salt since we have the ammonium cation and the chloride anion. So, let's balance this reaction. So I wrote it kind of funky, but it's fine because it's just saying that the reactants turn into products. It means the same thing, but just written a little bit weirdly. But naturally, or in normal circumstances, you want to write your chemical reactions in a straight line. But I'm just showing you another way that it can be written. So these two react to form this. So let's count the number of atoms on both sides. So we have 1 nitrogen on the top, 4 hydrogens on the top, and 1 chloride or chlorine on the top. And on the bottom we have 1 nitrogen, 4 hydrogens, and 1 chlorine. Looks like this is perfectly balanced. So look at that, we don't even have to add any coefficients to this. Our full reaction is just this with coefficients 1, 1, and 1. But of course we don't write the 1s since it is implied if you don't write any coefficients. So now let's move on to our next problem. Our next reaction will be sodium oxide plus water to form sodium hydroxide. So let's try balancing this out. So I noticed that the sodium is only present in 1 compound on both sides. So let's balance the sodiums first. So we have 2 sodiums here and 1 sodium here. So let's just multiply by 2. And now let's count the atoms. So 2 sodiums, 1 oxygen, and well, actually there are more than 1 oxygen. There are actually 2 oxygens since I forgot that there are oxygens in the water. And we have 2 hydrogens. Now on the right side we have 2 sodiums, 2 oxygens, and 2 hydrogens. Hey, look at that. Our reaction is perfectly balanced, and apparently this is our balanced chemical reaction. Let's move on to our next chemical reaction. We have lead 4 nitrate. So notice how the 4 refers to 4 nitrates, and that's why nitrate is in parentheses. And then we have to add calcium chloride. And then that will transform into lead 4 chloride. And last but not least, calcium nitrate. So now that we wrote this reaction, let's try to balance it out. So let's figure out how many atoms are on each side. So 1 lead, and look what I'm going to do here. I'm going to count the number of nitrates instead of the number of nitrogens and oxygens, since on both sides the nitrate is always NO3 and it doesn't change at all. So let's just consider it in terms of nitrates. So we have 4 nitrates. So let's not, separate it into 4 N's and 12 O's, because that can get a little bit complicated. And we don't need to do this since NO3s stay constant on both sides. Now we have 1 calcium and, 2 chlorides. And then on our right side we have 1 lead, 4 chlorides. So let me write the chlorides actually down here. 1 calcium and 2 nitrates. So we can balance something out. So everything looks like it's not balanced. So let's try balancing the chlorides first. So we need, 2 more chlorides. So I would just put, a 2 here. And, let me erase this and rewrite it. So calcium and 2 and then plus. So we need 2 calcium chlorides. So we would end up with 4 chlorides and 2 calciums. And look, our chlorides are balanced, but our calciums are thrown out of whack. So let's fix that. If we want 2 calciums on the right side, we simply put a 2 here. And that would give us 2 calciums and, 4 nitrates. And look at that. Everything is balanced, coincidentally. 1 lead, 4 nitrates, 2 calciums, and 4 chlorides on both sides. So this is a balanced reaction, and now let's move on to our next problem. So this will involve charges. So aluminum plus H plus becomes H2 plus aluminum 3 plus. So how do we balance this? Well, let me give you the states of matter first to give you some practice. Aluminum metal is a solid, H plus is a cation in solution, and we get H2 gas and aluminum cation, which is in solution. So how do we balance this? Well, remember, this has charges, so we have to follow the rule involving charges, that the atoms have to be equal, but the charges have to be equal on both sides as well. So let's keep a note at that. So both sides have, 1 aluminum. Seems like this side has 1 hydrogen and this side has 2 hydrogens. And the charge on the left side is +1 and the right side is +3. So now let's get to balancing. So we want 2 hydrogens on both sides, so let's do that. So if we put a 2 here, then we would have 2 hydrogens. And don't forget the +2 charge, since we have 2 + 1 charges, so it's +2. And now we have a balanced reaction. Well, not quite. This is +2 and this is +3. We have a huge problem. How are we going to fix this? Well, let's try a few things. So what I like to do is I like to find the least common multiple of the two. So the least common multiple of the two, this is 2, 4, 6, this is 3, 6. Hey, look, 6 is the least common multiple. So we are going to try to make it so that both sides have a +6 charge. How do we achieve that? Well, we can make 1 aluminum into 2 aluminums, and this would make a +6 charge, since if each aluminum is +3, then 2 times +3 is +6. And now let's make it +6 on the right side. So how do we do that? Well, if we want 6 charges, then instead of doing +2, we have to make it +6. So if each H is +1, then we need 6 of them. So we need 6 H pluses, so we'll have 6 H's now. So, but that throws the atoms out of whack. So how do we fix the atoms? Well, we need 3 H2s to make 6 H's. So look at that. Our atoms are now balanced. Oh wait, we forgot one thing. We forgot this. We forgot, 2 aluminums on the left side. So now we have 2 aluminums on the left side, 2 aluminums on the right side, 6 hydrogens on both sides, and a +6 charge on both sides. I think that's a mission success. Now, there are more efficient ways to do this, but that will be covered when we talk about oxidation and reduction, which we are not going to talk about right now. So let's move on to some other types of reactions. So let's try writing balanced reactions given, the words. So if I said chlorine gas is heated with sodium metal to produce sodium chloride, what would you say? So let me just write that out. So we know that chlorine gas exists as a diatomic molecule because it's one of the 7 we had to memorize. So it's Cl2 gas. And then we add sodium metal. So sodium metal is just, Na, because, sodium metal is an element, and If you're not given more information, just assume that it has a subscript of 1. So chlorine gas and sodium metal react to produce sodium chloride. And sodium chloride is a solid as long as it is not in water. So this is our reaction. So how do we balance this? Well, if I put a 2 here and 2 here, it's balanced. So it's up to you whether you want to write out all the chemicals or if you simply just want to eyeball it and see if it works. But either way, you get the right answer, and that's all that matters. So let's get to the next question. Sucrose, C12H22O11, which I assume is a solid since it's a sugar, decomposes into solid carbon. So solid carbon, if it's not a diatomic element, then it will have a subscript of 1 unless otherwise specified. So it's solid carbon and water. And solid carbon is a solid and water is a liquid. In the presence of sulfuric acid. Now, sometimes when people say the presence of, it can be part of the reaction, but in this case, it is not a part of the reaction. Instead, it is written up here, H2SO4 aqueous. So it's written up here because it doesn't participate in the reaction, but it kind of pushes the reaction forward, just like how heat pushes this reaction forward. So I could have drawn, heat or a triangle, which means the same thing as heat. So this just helps push the reaction forward, and in the same way, the sulfuric acid pushes the reaction forward. So how do we balance this? Well, 12 carbons, 22 hydrogens, and 11 oxygens. Over here we have 1 carbon, 2 hydrogens, and 1 oxygen. Let's balance the carbons first. So we want 12 carbons, so let's put a 12 there, and that makes 12 carbons. Let's balance the hydrogens now. So, you need 22, and you have 2, so I need 11 of these. So 22 hydrogens and, 11 oxygens. And look at that, it's all balanced. So we need 12 carbons and 11 waters. So apparently, when sucrose decomposes, it forms 12 carbons and 11 water molecules. Now let's move on to our final reaction. Sodium bicarbonate. So bicarbonate is also hydrogen carbonate, so this would be NaHCO3. And note that it doesn't talk about anything about it being in water, so it's a solid. And this decomposes upon heating, so let's draw a triangle, into sodium carbonate, NaCO3. Oops, we had to put a 2 there since this is -2 and this is +1. Let me undo all that. So Na2CO3 plus H2O plus CO2. Now I wrote it down here because, I was running out of space, but if you can, just write it off to the side and don't do what I'm doing. I'm just doing what I'm doing because I ran out of space. So let's try to balance this. So on the left-hand side, we have 1 sodium. And what do we do about the carbonate? Do we want to keep it as it is, or do we want to separate it? Well, I think I want to separate it because it seems like the carbon is being separated into both here and here. And what's even more interesting is that the oxygen here is going to all 3 of these. So I shouldn't keep CO3 intact because it's not really intact. It actually spreads over to 2 other molecules. So let's separate it. So we have 1 hydrogen, 1 carbon, and 3 oxygens. On the right-hand side, we have, 2 sodiums, 2 carbons. Let's count how many hydrogens. 2 hydrogens. Here, let me switch this so that it, lines up. 2 hydrogens, 2 carbons, and how many oxygens? Well, 3, 4, and 6. So we have 6 oxygens. So this looks like a pretty complicated thing to balance, and it might be actually. So let's try to balance this. So 1 sodium to 2 sodiums, let's try to fix that. So let's multiply this by 2. And if we multiply by 2, then we get 2 sodiums, we get 2 hydrogens, we get 2 carbons, and 6 oxygens. Oh wow, look at that. It balanced itself. 2, 2, 2, 2, 2, 2, 6, 6. So sometimes when you balance stuff, miracles happen and you are saved. And this was a great example of that. So let's now put some states. So sodium carbonate is a salt, which is not in water, so it's a solid. Water is a liquid. Well, actually, since it's done under heating, which is fire, the water might actually evaporate, so it might be a gas, and carbon dioxide is always a gas. So that's all for this video. I hope you learned a lot, and I hope you learned how to balance chemical reactions. Have a nice day.